page 86. My scaffold this time is a copy of this little table from, I believe it's page 6. Let me look back. Yes, your reference on page 6 will help you on this problem, or on these problems. A hill slopes upward at a 20-degree angle. So here's 20 degrees. Here's the hill. Find the cosecant of the angle if the hypotenuse of the triangle, and they just come right on out and tell me that the hypotenuse is 100 feet. And that's all the information they give me. They want us to find cosecant. This is what we're actually looking for. So if I go to, let me go ahead and put opposite and adjacent in here too, just so you can see those. If I look at my chart here, I can see that cosecant is defined two ways. It's hypotenuse over opposite, or it's 1 over the sine of theta. So let's see which of those, and possibly sometimes you can use both of those, but let's look at this. Cosecant is hypotenuse over opposite. So we have the cosecant of theta, which we do know to be 20 degrees. We do know the hypotenuse. We do not know the opposite, but we could find it. I'm going to call that x. The problem is that there's no cosecant on the calculator. If the calculator would do this for me, we could do it this way, but this is not on the calculator. We have cos, sine, and tan. So this method for this calculator is not going to work. This is not what we need. So the only other choice I have is to try this version of cosecant. And since I do know theta, this one will work for me. Cosecant of 20. We don't have that on the calculator, so we can't do anything there. But I do have sine on my calculator. So if we type this into the calculator, we're going to know this one. The cosecant of 20 is whatever this is. So let's put it in the calculator and see. And to do that, let me get some, oops, I lost them. Okay, I'll just put the calculator steps right down here. I want them in boxes though, because otherwise they get all mixed up with the problem and you can't tell what's what. So bear with me. You can go ahead and put it in your calculator and see what you come up with. If I can make that go away and copy this. Well, guess that's not going to work. Okay, here we go. Calculator, the first thing you should press is all clear. And then we want to put in 1 divided by 20 sine equals. So those are calculator steps right there. And now I can't find my calculator. Here it is. Okay, all clear. 1 divided by 20 sine equals. And it's not exact. Well, that is, but this number is not. It is approximately 2.9 2.92. So the cosecant is 2.92. And we had to use the reciprocal function to find that. Just because my calculator won't do cosecant. If it would, if yours does, then you can just do that and get your answer straight away. But the 100 is irrelevant in this problem because we don't have cosecant on the calculator. All right. A ski lift rises. So that would make me think that maybe it's this one. At a 25-degree angle. So it is this one. It's if it were rising at a 90-degree angle, it would be the opposite, but it isn't. So this is opposite. Here's hypotenuse. And once I know where theta is, I know which is adjacent. All right. So the ski lift rises at a 25-degree angle. Find the cotangent of the angle if the horizontal distance covered, so that's this number, is 200 feet. So let's see what we can do with our chart right here. It's probably a blessing in disguise that I didn't get this to copy. All right, so let's look for cotangent. And there it is. Cotangent of theta is the adjacent over the opposite. So let's set that up. We have cotangent of 25 degrees is the adjacent, which is your 200, over your opposite. And I'm going to use X for that. This would work just fine, except we don't have cotangent on the calculator. At least not this calculator. So that won't work. I'm going to use the reciprocal function, which I know to be tangent. Tangent is the reciprocal of cotangent. So I can tell you with that information that cotangent is the reciprocal of tangent. And I do have tangent on my calculator. So to put this one in the calculator, we're going to do all clear. 1 divided by 25 tan equals. So the cotangent of 25, and I'm betting it's approximately, but I don't know until I work it. 1 divided by 25 tangent equals about 2.14 if you round it to the hundredths place. So this is a reciprocal function. That's why you need to know the reciprocals. That's why I gave you this information on your chart. And this one especially, I believe you will use in electricity. So we'll spend more time on that one down the line. A lighthouse casts a shadow of 60 feet. So here's the lighthouse. I would assume that there's a light up here that's shining out across the water. 60 feet. I'm sorry, 60. I'm all messed up. Let's start over. A lighthouse casts a shadow of 60 feet when the sun is at a 50-degree angle. Find the secant of the angle. So our adjacent is going to be that one. Our opposite is the lighthouse, and then the line of sight for the sun is your hypotenuse. So secant, right here it is defined as h over a. So the secant of 50 is hypotenuse, which we don't know, over adjacent, which we do know. And if my calculator could do secant, I could use that. But my calculator doesn't do secant. So I'm going to have to use the reciprocal function. And I know that secant is the reciprocal of cosine. My calculator will do cosine. So we know that secant of theta is the same as 1 over the cosine of theta. And my calculator will do this one, the reciprocal. So to put it in there, you want to say all clear. 1 divided by 50 cos equals. So all clear. 1 divided by 50 cos equals. So the secant of 50 is approximately 1.56 using that reciprocal function. Okay, this last one will not use a reciprocal, so we'll just work it the way we've been doing it. I am going to take a second and draw in my variable box, just because that's what's familiar. H O A theta. A boat is sailing toward a lighthouse. So I'm going to say that this is my lighthouse. Here's the boat, and it is vectoring toward the lighthouse. Here's the light on top of the lighthouse. If the angle of elevation to the top of the lighthouse is 15 degrees, so that would be this direction from the boat to the lighthouse up here, 15 degrees, and the lighthouse itself is 200 feet tall. Usually that's what they want me to find, but this time they're telling us how tall the lighthouse is. And here would be adjacent to theta. How far is the boat from the lighthouse? So we want to know this distance from the boat to the lighthouse. So adjacent is the question mark. Opposite is 200 feet. We don't care about hypotenuse this time, but we do need theta. So we want the ratio that puts O with A, and that's TOA. So the tangent of theta is opposite over adjacent. And that's what we don't know. That's the distance we're looking for. So I'm going to move D for distance and cancel. And that's one of those tricky ones. We need to isolate D. Let me just rewrite it right here. D is stuck onto that tangent of 15. We can't have that. We've got to get D separated away from that. So let's move tangent of 15. Do it to this side as well. You can bring the brackets if you need them. They're just separating the D out. So D is 200 divided by 15 tangent. So D is approximately 746.41 feet. Again, when the number's that big, the rounding is not as critical. That number makes sense to me, that the boat would be that far away. I wouldn't expect it to be 7 feet from the lighthouse because that would be awfully close for comfort. 746.5 feet roughly is about right.